on is understanding what the inverse trig functions are, okay? So let's go back to Algebra 2. In Algebra 2, your teachers said that the really important thing about inverses is you literally switch x and y. So if I asked you to find the inverse of f of x equals 3x minus 4, you can think of f of x as just y. So what I'm going to do to find its inverse is literally just switch places with x and y. And now what we're going to do is get y by itself. So I'll add 4, and I'll divide by 3. Okay, so you'll typically see it written like the heart method, where I have x over 3, or you could do 1/3 x plus 4 over 3, which is 4/3. We're going to indicate that it's an inverse function by using that little -1 as your exponent. Okay, now it says graph f of x equals 3x minus 4, and its inverse on the same set of axes. So I'm going to graph the original function in blue. So it's a line, so I'm going to go ahead and plot the y-intercept first, and a slope of 3 means I'm going to go up 3 over 1, up 3 over 1, up 3 over 1. Okay, so there's that. Then the inverse is what we just found, 1/3 x plus 4/3. Okay, so 4/3 is going to be right here, and your slope is now up 1 over 3. Up 1 over 3. Up 1 over 3. Okay, and if you want to continue it on over here, you can do that as well. Cross right there. Alright, so as a reminder, what you're really doing is reflecting your original function across the diagonal y equals x. Okay, so if I were to fold my paper along this diagonal, y equals x, the blue is going to land on the pink, or the pink will land on the blue. Alright? So the third question asks you to find the inverse of y equals sine of x. So the first thing I'm going to do is switch x and y. I have to try to get y by itself. And if you remember from the first unit, okay, we found something to undo sine. And how do we undo sine? We take the inverse sine of both sides. So if I take the inverse sine of y, I'll just get y by itself. Okay? So there are actually two ways you could write inverse sine. You could write it just like this, or you'll see it written sometimes as arc sine. Okay? So if I had the inverse cosine, you'll sometimes see it written as arc cosine. And lastly, inverse tangent could be written as arc tan. Okay? So we're going to take a look at some problems, and you guys actually on your warm-up started doing this earlier. It says evaluate over the interval 0 to 2 pi. So it includes 0 and also includes 2 pi. All the answers should be in radians. Okay? So one way you could do this is really just take a look at your unit circle and have that out at all times, but I don't think a lot of us really use the unit circle that much. I think a lot more people prefer to use the reference angle chart. So let me go ahead and write that out. So we have 0, pi over 6, pi over 4, pi over 3, pi over 2. We're going to have sine, cosine, tangent. So 0 to 1, 1, 2, 3. And cosine's 1 to 0, 3 to 1. And tangent is sine divided by cosine. Okay, so now that we have that done, I am going to use a mixture of this as well as that all students take calculus to help me figure out the angles that are going to be the answers. Okay, so for number 1, what we're thinking is, okay, what's the inverse sine of root 2 over 2? So in our heads, we're thinking, what angles would have a sine value or y value of root 2 over 2. Okay? So if you were to look on your reference angle chart, here's sine. One of the answers, so here's root 2 over 2, is pi over 4. So y is equal to pi over 4. Okay? But according to all students take calculus, okay, sine is positive over here, so there's that pi over 4. It's also positive over here in quadrant 2. So I need to figure out what's that angle in quadrant 2 that would give me pi over, or at least give me a sine that's equal to root 2 over 2. Okay, and it's going to have the same reference angle. So if my reference angle is pi over 4, here's 0. Remember over here it's going to be 4 pi over 4. If I take away 1 from 4 pi over 4, that would give me 3 pi over 4. Okay? This chart is going to help you at least with your denominator. Okay? So it's always going to tell you what the bottom of your fraction should be. You're going to choose the angle, whether it's subtracting 1 from 4 pi over 4, adding 1 from 4 pi over 4. Maybe you had to go all the way around, that's 8 pi over 4, subtract 1, okay? So it's always going to be adding 1 or subtracting 1. Alright, so let's try another one. Inverse cosine of root 3 over 2. Okay, so I'm going to do all students take calculus. It's a positive root 3 over 2, so I know I'm not going to have an angle in the second or third quadrant. It's got to be from the first, and I'm also going to have an angle in the fourth quadrant. So let's take a look. Cosine. Root 3 over 2 is right here. So pi over 6 is the one that's going to be in the first quadrant. If I go all the way around, this would be 12 pi over 6. So one less than that, a little bit less than that, would be 11 pi over 6. Okay? Now, one trick that I always tell my students is if you can reduce your fraction, you chose the wrong angle. Okay, so if this is 12 pi over 6 and you said, okay, maybe it's 10 pi over 6, I know 10 pi over 6 can be reduced down to 5 pi over 3. So that would have been a wrong answer. 11 pi over 6 can't be reduced. All right, let's take a look at number 3. Arc sine of negative 1/2. Okay, so we're looking for quadrants that have a sine value that's negative. Okay, so that would be over here in quadrant 3 and also over here in quadrant 4, because all students take calculus. So let's figure out what's our reference angle. So I'm going to go up to my reference angle chart. So we're looking for sine 1/2. My reference angle would be pi over 6. Okay, so here's pi over 6, so definitely not that as an answer. And it can't be in quadrant 2. So if this is 0, this would be 6 pi over 6. A little bit more, if I add one more, would be 7 pi over 6. If I went a full circle, that would have been 12 pi over 6. So a little bit less would be 11 pi over 6. All right, I'm going to jump down here to number 5. Okay, whenever you have arc sine or arc cosine of something, or sorry, of 0, 1, or negative 1, those are going to be our special cases. Okay, so what we're going to really focus on whenever it's the argument, so the number is 1, negative 1, or 0, is those quadrantal angles. So I'm going to draw those right here in the middle. So you got 0, pi over 2, pi, 3 pi over 2. And then if I went all the way around, it'd be 2 pi. Okay, the ordered pairs that we have here are 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay, so number 5 is asking us to find the arc sine of 0. So we're thinking what angles would have a sine value, so we're thinking y value of 0. Okay, so let's take a look. If I go around this unit circle at my quadrantal angles, the ones that have a y value of 0 would be 0, pi, so let me list these out, 0, here's pi, and went all the way around, be 2 pi. So all 3 would be my answer. Okay, let's take a look at number 6. Arc cosine of -1. So we're thinking in our heads, what angles would have a cosine value, so x value, of -1. Alright, so let's look. Nope, nope. Right there, pi has a x value of -1, but not 3 pi over 2 or 2 pi. So y is equal to just pi. Okay? Now we didn't do 4, 7, or 8, so go ahead and try to do those on your own and check your answer through Blackboard.